this lesson today, we're going to talk about how to rationalize the denominator. Rationalizing the denominator is the process by which a fraction is rewritten so that the denominator contains only rational numbers. If you remember back a couple sections ago, we talked about the rules that apply when simplifying a radical expression. Let's go ahead and review those rules. We took care of rule number 1 a couple sections ago. The radicand has no perfect square factors other than 1. So, for example, that was something like when we had the square root of 50, we could break that down into root 2 and root 25, giving us that 5 root 2. That was the first rule, which we've already taken care of. Now, the next two rules are going to apply in this section. So looking at number 2, the radicand contains no fractions. So for example, we cannot have something that looks like this. The square root of 2 over 5. It's not allowed. It's part of the simplifying rules. So I'm going to show you today how to eliminate that. Number 3, no radicals appear in the denominator. So I'm not allowed to have anything that looks like this, 2 root 5. Because I have that root 5 in the denominator. So you're not allowed to have that either. So I'm going to show you how to eliminate that in this lesson. All right, let's go ahead and rationalize the denominator. All right, before we do that, I do want to take a moment to just kind of think back. In a couple sections ago, we talked about the product rule. And the product rule looked something like this. We had the square root of a times the square root of b would equal the square root of ab. So we use that rule quite a bit in the last couple of sections. Well, today's rule is called the quotient rule, and it's called the quotient rule because we're dealing with division. So what it is basically is if I have the square root of a fraction, such as ab, I can break that into the square root of a divided by the square root of b. So I'm basically just breaking it into two separate square roots. That's called the quotient rule. So we're going to need the quotient rule in order to rationalize the denominator in these problems. So let's look at the first problem. We have the square root of 12 over 5. So the first thing we need to do here is we have to use the quotient rule. So I'm going to just go ahead and take a second and I'm going to break that into the square root of 12 and the square root of 5. Okay, so now I've broken into the top and the bottom. At this point, now you can do what we call rationalizing the denominator. So what I'm going to do is I'm going to take that denominator and I'm going to multiply the top and the bottom by that radical number. So in our case, it's radical 5, so I'm going to multiply the top and bottom by that number. Okay, I'm going to bring my work down here. What I'm going to do is you can see in the top problem here, I'm just going to change my pen color real quick, but in the top you can see that really all we have here is the product rule. We have root 12 times root 5. Okay, so what we're just going to do there, we're just going to multiply it, and that's just going to give me root 60. Now, in the denominator is kind of weird. I have root 5 times root 5. Now, I'm just going to go up here to the top here and kind of show you how this works. If I had root 5 times root 5, and I did the product rule, I would have root 25, which of course we would simplify that to 5. So basically, when you see two roots of the same number, this is the rationalization process. What that does is it turns it into 5. So I'm going to say root 60 divided by 5. Now, you've taken care of your your fraction under your radical, that was rule 2, and you've taken care of your radical in the denominator. You've rationalized it. But we're not quite done yet. So what I want to do now is I want to take my numerator. The numerator is probably staring back at you right now and saying, simplify me. So I'm just going to kind of come over to the side, and I'm going to say, what's the square root of 60? So if you remember from the past couple units, we don't have to figure this out, just off the top of your head. You can go into your calculator by going to your y equals, and that's where you would put this number 60 and divide it by x. And there, if you go ahead and do that and press second table, you'll be able to see all of your factors. So we want two factors that are going to break in 60. So I'm going to break it into 4 and root 15. If I continue to simplify this down, that's going to give me 2 root 15. So what I'm going to do now is I'm going to take that simplified answer and I'm basically going to take them back and I'm going to replace the numerator. So I'm going to replace them down here. I'm going to say 2 root 15 divided by 5. Now the last thing you want to do in rationalizing the denominator is you want to look at those coefficient numbers. In our case, we have a 2 in the numerator and a 5 in the denominator, and 2/5 is a number that cannot be simplified. So at this point, you are finished with your problem. Okay, let's go ahead and try another one. All right, this time I do not need to apply the quotient rule because it's already set up for us. All we need to do now is go straight into rationalizing the denominator. So I'm going to multiply the numerator and the denominator by that bottom denominator root, and then I'm going to go ahead and simplify it. The product rule is going to be my numerator, so I have the square root of 6 times the square root of 8. That's going to leave me with the square root of 48. And my denominator is going to be root 8 times root 8, which I know just simplifies to plain old 8. Okay, what we want to do now is we want to take our 48 and we want to just take him off to the side. You can take him to the right or to the left, it doesn't really matter. I usually, out of habit, just put him over here to the left. And I want to break that down. This is where you can go into your calculator and find those factors. My two factors are going to be 3 and 16. And I can continue to break that into root 3 times 4, and that's going to leave me with 4 root 3. All right, I'm going to take that number, and I'm going to take him up into the numerator of my fraction. So I have 4 root 3. And if you remember from our original answer here, 8 was in my denominator. So I'm going to rewrite that. The last step I want to do is I want to look at my coefficients. And you can see that my coefficients are 4 and 8. So 4 and 8 can obviously simplify. These are the two coefficients that I'm speaking of. So 4 divided by 8 is going to give me 1/2. So my final answer here will be root 3 over 2. And I wrote it as root 3 over 2 because we don't really need that coefficient in front of the root 3. The root 3 kind of acts kind of like a variable in a sense. So this is my final answer. This is my simplified radical expression. Okay, let's try a couple more. And I'm progressively getting a little bit more challenging as the problems go on. So you can see in the second problem here, I'm going to be adding some variables. So let's try this next one here. All right, so this one's a little bit different because now I have the coefficient of 2 in the front. I'm going to show you how that applies here. So I'm already broken up into the quotient rule, so I'm going to go ahead and I'm going to rationalize the denominator. I'm going to multiply the top by root 15, and I'm going to multiply the bottom by root 15 as well. All right, at this point, this is where it gets a little bit different. Okay, what I need to do now is I need to multiply this 2 root 25 times root 15 using the product rule. So a great thing to do in this case is to just kind of look at your coefficients. And first I have 2 and I have a 1 and I'm multiplying. So my coefficient is going to be 2. But then I have root 25 times root 15. That's kind of weird. But we know that that's the product rule. So what I'm going to do here is I'm going to write root 375. And I got 375 by multiplying 25 by 15. Okay, so now that my numerator is done, let's go ahead and do my denominator. Root 15 times root 15 is going to give me a nice 15. Okay, now that I have that, what I need to do is I need to take my numerator and I need to take him to the side and I need to simplify him down. So I'm just going to kind of bump him over here. I have 2 root 375. So obviously I have 2 and I'm going to multiply that by 375, but I need to go into my calculator and figure out that 375. And I can see that there's already a 75 at the end, so that might be kind of helpful to us. Yes, it is. So 375, that's going to break into root 15 and root 25. And if we just continue the simplification process, we're going to end up with 10 root 15. Okay, so we're not done. I'm going to go ahead and I'm going to take that and I'm going to put them in the numerator. So now I have 10 root 15 in my numerator. And remember my denominator, I'm going to go ahead and put 15 in the bottom. As you can see, my coefficients are not simplified, so I'm going to go ahead and simplify that. 10 over 15, well, that's going to give me a nice 2/3. And I'm going to go ahead and finish it off with my radical in the numerator. So as you can see, all three rules are satisfied, and we are completing, the problem is completed at this point. Okay, now let's get to the fun stuff. Let's go ahead and let's add some variables. This will be fun. All right, I'm going to treat it exactly the same way. All right, let's go ahead and rationalize our denominator. I'm going to multiply the numerator by 5p squared. And I'm going to multiply the denominator by the same thing, 5p squared. So I haven't changed anything at this point. If you want, you can go ahead and put your denominator in there because that's pretty easy, right? If we multiply those two, it's going to give me 5p squared. All right. Now the top. Let's go ahead and multiply them. If I multiply these, I'm going to get 4p with a root 5p squared. Okay. All right. At this point, I'm going to treat it exactly the same, and I'm going to go ahead and drop my numerator down here to the bottom, and I'm going to go ahead and simplify that radical expression. And we did this a couple units ago when we talked about laws of exponents and simplifying, and let's go ahead and simplify this. So it looks like I have 4p times, I'm going to break it down into root 5 and root p squared, and then I'm just going to simplify from there. I have 4p, root 5 doesn't simplify, but I know p squared simplifies to plain old p. So I'm going to put it back together. Now I have 4p squared root 5. All right, there's my numerator. So I'm going to go ahead and I'm going to go put him in my numerator. I have 4p squared root 5. And then in my denominator, I have 5p squared, and that's just from up above. All right, this might be bothering you at this point. You might be thinking, well, I have p squared in the numerator and I have p squared in the denominator, and neither of them are underneath a radical. So you're exactly right. I'm going to use the rule where I take my p squared in the numerator and I subtract that exponent. I say 2 minus 2, the one in the denominator, which happens to cancel them both out in this sense. And I'm left with 4 root 5 over 5, satisfying all of the rules. Sometimes you'll end up with a variable in the answer, and sometimes you won't. Excuse me. So let's go ahead and take a look at two more. And these will be the last ones we have for today, and they have some variables in them, so this will be fun. All right, let's go ahead and do the first one. I'm going to go ahead and I'm going to rationalize the denominator. Now, this one's a little bit different because if you look, we have a 4 coefficient in the denominator. That is not part of my radical. So when I rationalize this, I'm only multiplying the top and bottom by the radical that's in the denominator. That's it. So you got to be really careful about that. The 4 is not part of this situation here. Okay, now that we have that, we're going to go ahead and simplify this here. If I simplify my numerators, I'm going to get 5 and then followed by 3m squared under the radical. In my denominator, I know that this piece and this piece are going to leave me with 3m squared. But then I have this 4 that I need to deal with. The operation between the 4 and the radical is multiplication. So really, I'm saying 4, and there's a 1 here too, being multiplied. I'm going to say 4 times 1, and that operation between those radicals is multiplication. So I'm going to say 4 times that 3m squared. And of course, you can take another step there, and you can say, I'm going to rewrite my numerator, and you can say 12m squared if you'd like. But you know it, we're not done here. I need to take my numerator off to the side, and I need to simplify him. So if I simplify him, it's going to look something like this. Again, I like to break it into those pieces, and I'm going to be left with 5 root 3, and the square root of m squared is going to leave me with m. So I'm left with 5m root 3. Okay, I'm going to take him back up into my numerator. 5m root 3. divided by 12m squared. Okay, well, you can see here that we're not quite done either. You can see that we have an m in the numerator and we have two m's in the denominator. So there's two ways you could do this. You could take that 1 and subtract 2 from it to give you -1. Or you can notice that there's 1 at the top and 2 at the bottom, which means that one of them is going to eliminate in the numerator, but when you cancel out 1 in the denominator, is going to be 1 left. Meaning your final answer will be 5√3, because that m disappeared, divided by 12m. And there you have it. Okay, let's look at a really heavy one here. Lots of variables going on here, but we're still going to treat it the same way. All right, I'm going to go ahead and I'm going to multiply this by the radical that I have in my denominator. So I have √3b squared. Cubed. All right, and let's go ahead and simplify this. If I simplify the numerator, I'm going to do the straight product rule. So I'm going to have √12. And then if you remember your the rule where we just had b squared times b cubed, when we have those like bases and we're multiplying them, we're going to add those exponents. So that's going to leave us with b to the 5th. Okay, and then my denominators, again, these two pieces are identical. So I'm going to label that as 3b cubed. And I'm going to multiply that by that number that's sitting out front, which is 4. Okay, I'm just going to take another step here, and I am just going to rewrite my numerator and simplify that denominator. All right, you know what to do. I'm going to go off to the side, and I'm going to write 12b to the 5th. And I'm going to go ahead and simplify that. So I have 12, and I have b to the 5th. So the 12, that's pretty easy. I'm going to split that into 4 and 3. And my root b to the 5th, if you remember correctly, this is the weird one where we have to, it's an odd number, so we have to subtract 1, which is 4, and then divide it by 2. And that will give us b squared, and then we follow it by a b. One more step here. Let's go ahead and simplify that perfect square. And then we're going to go ahead and just piece it together. So I have 2b squared √3b. All right. I'm going to go ahead and take him back up. 2b squared √3b divided by that denominator from right above, so 12b cubed. Okay, we have some simplifying to do here. A couple things we need to do. So first of all, 2/12. Okay, 2/12, that's going to give us 1/6. So I'm just going to put a 6 in the denominator, and you can put the 1 up top if you like. Then I have b squared and b cubed. That's going to leave me with 1b on the bottom. And I have √3b. That's going to be left on the top. So everything is simplified. As you can see, I have a b under my radical and then a b underneath. You cannot simplify a b or any variable that's underneath the radical and one that's not. All right, so that is the lesson on rationalizing the denominator.